variables here, and I numbered them, as you can see, 1, 2, and 3. And I'm looking at them and I'm realizing this one has an x and a y, this equation has a y and a z, and this one has an x and a z. So it's not really easy for me to eliminate anything. So I'm just going to pick one and see if I can maybe do a substitution. And I'm just going to pick number 1. I'm going to rearrange number 1 and isolate y on one side of an equation. So I just rewrote that, and I have 2x plus 3y equals a negative 2. And I go about rearranging minus 2x, minus 2x. And I'm left with 3y equals a negative 2x minus 2. And then I decide to isolate the y, so I divide by 3. And I have y equals a negative 2/3 x minus 2/3. And I'm going to label that number 4. Okay, so now I'm looking, all right, I have a y. Can I use that in one of the above equations? And oh boy, there it is. I can either plug it into number 2, and that's probably my best choice. I just rearranged number 1, and I'm going to plug it into number 2. Okay? So I start with problem number 2. 4y plus 2z equals a negative 10. And I plug that y in, and I have 4 times the y value that we had created here, plus 2z equals negative 10. I do my distributive property, and then I'm going to combine like terms, so plus 8/3 plus 8/3. I know that I have a negative 10, so I'm going to change 8/3 into 2 and 2/3. And I'm also going to rename 10 to 9 and 3/3 to make my combination a little bit easier. And so I know that I have 9 and 3/3 plus 2 and 2/3 is 7 and 1/3, a negative 7 and 1/3. And I'm putting it back into an improper fraction. And I'll show you why I want to keep that as an improper fraction in a second. Okay? All right, so I now have 2 variables. And before I want to move on, I decide to get rid of the fraction. And because this one happens to be a third, and this one is 22 over a third, I know that I can get rid of the fraction by multiplying each term by 3. Really important to remember. If I'm doing something like that, I have to multiply each term. So I have 3 times negative 8/3, and I know that my 3's will cancel out. So I'm left with 8z. 3 times 2z is 6z, and my 3's cancel out here, and I have a negative 22. And I now have an equation no fractions in it, which would make it a little bit easier for me to work with. And I've labeled this one equation number 5. All right, so the next thing I'm going to do is I go back to my originals, and I'm looking, oh, look at that. Equation number 3 has an x and a z in it, and my new equation 5 has an x and a z in it. I'm going to use elimination with number 3. So I am going to look at these, and I'm thinking, well, it's not obvious, and I'm choosing to multiply the top equation by negative 5, and I'll multiply the second equation by a 6, and by doing that I can eliminate z. Combine like terms, 40x plus 18x is 58x. Plus 1 equals 116, and I know x is 2. Well, that's good information to have because, again, going back to my 3 equations that we started with, if I know what x is, I can either solve for z or I could solve for y. And and I decided, using x equals 2, I plugged it into equation number 1, 2x plus 3y equals negative 2, and I will solve for y, and I have 4 plus 3y equals a negative 2, subtract 4 from both sides, 3y equals a negative 6, and y is equal to a negative 2. So now, I have my x and my y value, and you know that you could solve for z easily, and I plugged it into number 3, equation number 3. So I have 5x plus 5z equals 1, plug in x again into this, and I have 6 plus 5z equals 1, subtract z from both sides. 5z equals a negative 5, and z equals negative 1. So I have now x, y, and z, and I know that I always want to check. And when I checked here, I have just plugged it into number 2. I've used, I believe this is equation number 3 to solve for z here. So I'm going to choose a different one to see if it checks. So 4 times a negative 2 plus 2 times a negative 1 equals a negative 10, and I can see that they check. Okay. Let's just look, just want you to look from the beginning. Where are we here? And this took me a lot of, it's a lot of work. It took me a lot. I have a page on this side of work. And I continued on to a second page, and I continued until I got here. So one problem took me a page and a half. Okay. Hope that helps. We'll go on to the next problem.